We will now take questions from the audience. There are microphone assistants in the room, so whoever wants to ask anything to the speakers may please raise a question.
This is about buildings with facades which are not, linear, or which are twisting or not in a straight line. I do understand that in terms of gravity, it is not beneficial, but in terms of the wind loads, does it help that it avoids vortex shedding and, effectively your wind loads get lesser, but your gravity loads increase? So effectively, is it balanced out, or do you still think that it's not a good or an optimal structural system to direct it to specifically?
Yeah. Well, it's a good question. What I would say, the question was about the effect of twisting facades on wind performance and versus my comments earlier about the gravity performance. And I think you can have it both ways. It's true that the twisting facade, like the spoilers that Bill Baker referred to in his morning presentation, do reduce vortex shedding. In fact, when we did the wind tunnel testing with RWDI on the Chicago Spire, there was tremendous reduction just in modifying. We had several different schemes for different twist arrangements, and they had different results. The one we chose was the optimal result, but there's no question that versus a smooth cylindrical tower performs better in the wind. My comment was about what structure supports that spiral motion. And generally, if you have a spiral structure under gravity load, it will actually tend to untwist itself, if you know what I mean, and induce, in a sense, permanent forces in the structure. So you can design for that, of course, but sometimes structural engineering is about design avoidance, trying to avoid the problem rather than just solving a problem.
Yeah, I think in some sense, as he mentioned, the wind forces will significantly reduce, not the forces, but the vortex shedding and perception to motion. However, we must just not overlook the cost of the project, because the gravity load is it ends up generating a huge amount of forces, and to level they become unmanageable. So a proper selection of a structural system that minimize that change and plays a very important role in optimizing the structure. And you don't really necessarily need to pay extra money to achieve those. But there's a lot of architectural planning that has to be done with the structural engineering and constructability aspect of the project in order to be able to achieve it. So collaboration between the architect, the engineer, the contractor become a very important thing to do from the early onset of the project. As I showed on some of the slides, and I went through them very quickly, some of these projects will end up being 50% of the total cost of the building. That's absolutely huge. I mean, nobody is going to pay for that. However, by making minor changes to the architecture, the core, in fact, sometimes you can strengthen the design rather than take away from it, but you can reduce the cost significantly. So there is an interactive process that has to take place between all the architect, the engineer, the contractor, to come up with an optimum solution for the design. The other issue is, beside what you just looked at, is the cladding effect, the building services. Is it concrete? Is it steel? The long-term effects. You end up getting into a lot of other technical issues that goes beyond just wind engineering. It ends up being the overall performance of the building. And that's the most critical thing we need to look at with these towers.
I think you had a question here.
Hello, I am Harish Gupta. I am an architect. I have a very simple question. It's not very technical. Everything has a life. What do you think is the life of these buildings? The facade will have a life, the structure will have a life. And what do you do at the end of that lifespan?
Well, obviously, we design building for a certain lifespan, but as you know, the technologies are constantly changing. building the Empire State Building 100 years ago is still operational today and is still functioning as it did before. But obviously we have new technologies in order to, you need to keep upgrade with the building for people to be able to make it usable. So the lifespan when you build these super tall buildings, we design them actually for a very rare, especially structurally rare event. But they are expected to be upgraded with time to keep up with the new technologies, related functionality, services, energy, cladding, performance, durability, maintenance, all of these issues in order for the building to survive for the ages has to be done.
Yes, please.
Yeah.
I'm Rick Keating. I actually believe that in the future some of the super tall buildings will be linked together, as we've seen in the Maras Tower and some of those, bracing each other, for example. And I also know that in Maras there was an effect on the second building in the wind tunnel behind the first one in terms of the wake. And I see the one in Korea, and I wondered if that's been tested in the wind tunnel and what the twin tower out in Incheon. And any of those kind of comments you might have about that engineering of a twin tower or a triple tower?
Absolutely. Obviously, we've done a lot of testing on those, and the distance and the opening between the two towers play a very important role. And obviously, when you get sharp corner, you get really violent wind effects and vortex shedding formation depending on the directionality of the wind. We were able to introduce corner openings at the corner of the building to mitigate against that. And in fact, we were able to reduce that a lot. In addition to that, we rounded the corner and essentially we reduced the wind effects, both the overall wind loads and acceleration significantly. And we went through another round of discussions looking at how wide that opening is, to a point in which some of the studies that we've done previously in the wind tunnel, up to depth divided by 10, if you limit that opening, then you can overcome all the vortex shedding issues. And at this point, we are almost close to that. And Peter Irwin and I and DT and the design team went to the wind tunnel and looked at the flow visualization, and we have shown that there's a lot of benefit to some of these openings. As long as you control them, you can manage these issues. And with this opening at the corner, actually did reduce the overall wind forces and also the acceleration potentially of the building.
This actually, Rick, your question is a good one. Relative to what happens if the extending your question outward is the question, what if I build a building and I create bad behavior for somebody else's building that was been there for even 20 years? We had an experience like that, it never got built, where we did ask that question. We had one of our first attempts, Thornton Tomasetti's first attempts at topping the Sears Tower in Chicago was the Miglin-Beitler Tower in around 1990, and with Cesar Pelli. Interestingly, a precursor to Petronas Towers in terms of the structural system. But it went into the tunnel with at RWDI, and it turned out that when we were looking at all the different directionalities, that the direction from the Sears Tower created a bump in the performance, meaning there was an effect that Sears was having on this very slender tower. And so one of the questions that the owner had was, well, would we have an effect on Sears? And in fact, Peter did the opposite. I mean, he monitored the Sears Tower based on this proposed building. It turned out that because it was such a massive building compared to a much more slender building, it didn't have any effect. But it did raise the question, it's the same as sort of building in Canada. If you build somewhere and you create a snowdrift problem on your neighbor. So there are things you have to look at, but I think the solution to those is, who knows, that hasn't happened yet, but there are fixes, of course, as we know from the Hancock building and the Citicorp building in New York. You can build after the fact, certainly the Hancock building in Boston, you can after the fact add damping, which I suspect would be a solution if you had such a case like that.
We did run into actually a real problem with that. For example, the Jinma Tower, it's in between the Mori Tower and Shanghai Tower. And we anticipated that when we did the wind tunnel testing, and we tested the tower both during the existing conditions and the future condition. And in fact, what we found out that the forces and the acceleration of the building went up by about 50% because of the effect of adjacent towers. Fortunately, we included that in the design. This presents really an ethical question, and the whole planning issue is in terms of who really take care of these issues, because it could result into real serious problems sometimes.
In the morning, Dr. Young was talking about a building which is very tall but would have gardens all the way to the top, and everybody is using green terraces and sky terraces. Some of them are open. We are seeing a lot of buildings of that nature. In wind tunnel engineering and livability of that, are you modeling using that area in wind conditions? Or are you thinking of completely shutting off the wind with an 8-foot glass wall and just not using it in a windy condition?
It depends on how much you express it. You know, if it the texture is so pronounced and dimensionally is big enough, it could have some beneficial effect. It depends on how you articulate it, how you work with it. Ultimately, having a rougher surface at the exterior of the building does reduce the vortex shedding and break the vortices and make the building generally in a little bit better. But doing a vertical city and living in it, I think, in my opinion, I think with the very high dense cities, there is no reason why you cannot create and tie these buildings together and create these wonderful places and communities up in the sky. I think it's a great idea. Yeah.
You know, just to answer your question further, I think you were asking about the safety of open terraces high up, and those can be studied as well in the wind tunnel. Not just of course, ground wind studies where you're studying what the predicted wind pressures are for people, and obviously at some level it becomes unsafe. You can do that same study at high-level terraces, and of course, as you might imagine, at certain times of the year they would get dangerous to be on without some sort of protection.
Burj Dubai, as it tapers off, you have a number of terraces in each of the 3 wings. Are they usable in windy conditions?
Absolutely. In fact, during construction, even in windy area, sometimes, but obviously we tested, first of all, we tested all the terraces in detail, and when it is windy, we have put sonometers to measure the wind speed at that level, and it's automatically connected the building management system. So after a certain level, all the doors will be shut off or shut. They will not be able to open them. But in most of the day, actually, Dubai is not that bad. During construction, you go out to the terraces, and it's really comfortable for the majority of the day. There are some times where this could be, but it's not so often. And I tell you, for the last 4 years, been going up and down and standing on these terraces. They are extremely usable, and I'm sure people will enjoy them very much. Plus the fact that the windows are high enough. It's about 1.8 meter, where essentially the wind can flow above them. And so there's another level of protection that definitely will make it enjoyable for people to use.
Peter, you want to say something?
Yes, I just wanted to give, I'm surrounded by engineers, so I just wanted to give an architect's response to the gentleman who asked the question about the life expectancy of buildings, not from the perspective of embodied energy or the like, but really in terms of reusability. And one of the things that struck me during the presentations yesterday was this suggestion that the new blocks of flats which are being developed to move some of the slum dwellers out of Mumbai were going to be made up of flats of something like 200 square feet. I'm not sure if I got that figure right, but I think I'm right. And I guess, we have this concept in the UK now called lifetime homes, and the whole purpose of the lifetime homes concept is to ensure adaptability of a building, and I think that's a really important concept perhaps for you to consider here, because some of the blocks which I saw being built yesterday were RC framed and perhaps less flexible than they might be, and I wondered how long it would be before people's aspirations for larger homes put pressure on the stock that you're building now, and whether one oughtn't to think about that now in terms of being able to combine units 3, 200 square foot units into 6, however that might be, so that one could extend the life of these buildings.
Hi, I'm Jeffrey West of DTZ. My interest is in project management and actually making these projects happen, particularly here in Mumbai. Now, Peter started his presentation by saying, I've looked at Mumbai, I'm going to ask a question of what is success in Mumbai. I've enjoyed this conference enormously, but what I've seen is an aspiration that may go way beyond what Mumbai can achieve. Can the panel help the people in Mumbai manage that expectation, please?
What a question to end with.
We're going to let the architects respond.
Yeah, thanks a lot. I mean, the simple answer to that is we'd all love to. And I think going back to the slide that I put up about how do you define success, I think really that's a question that the people of Mumbai need to answer. But I think it's an important question to be asked, and I think it's important that you understand the answer before you start in order that you can evaluate the projects as they're being implemented. I'm not at all clear about the governance issues in Mumbai. I'm not at all clear about the planning policy, but other than it's very complicated. And from what I can remember of the presentation that was made yesterday by the Remaking of Mumbai Federation representative, he was talking about bringing a lot of these entities together into smaller, more focused groups. Now, that seemed to me to be a very good idea because there needs to be some coordinating body to make sure that all of this development works, one project alongside another, and that, as I said in my presentation, that the micro and the macro are conceived as one. It doesn't answer the question, but it's as far as I can go.
Well,
absolutely. Absolutely.
Well, I hope you have all been inspired and challenged by these discussions. With this, we draw this first session of the last day of the Ctbuh conference to a close.